It looks like we're out of time, but just to let you guys know that we have a test next week on spontaneity. Study really hard, go to SI, do whatever you need to do, and I'll see you next week. Oh, excuse me?
Mm-hmm.
Do you understand this?
Yeah, I did.
I don't quite get it yet, so can you help me, please?
Yeah, actually, I can help you, but I have to go somewhere right now, but I can meet you in the library in half an hour.
Okay, that's perfect.
Okay.
Thank you.
Sounds good. Hey.
Oh, hey!
How are you?
Good.
Good?
Good.
Okay, so I actually brought some stuff to help you out. So I'm going to draw it out for you, and hopefully you understand.
Okay.
So, chemical reactions are said to be spontaneous if the reaction favors the formation of products at the conditions under which the reaction is occurring. For example, the melting of an ice cube at room temperature. A reaction is considered to be spontaneous when the entropy of the universe is greater than zero, taking into consideration the change of the entropy of the system and the surroundings. Although it may be hard to calculate the entropy of the universe when performing an experiment, there is a thermodynamic equation that allows us to predict the spontaneity of a reaction. This equation is known as the Gibbs equation, where the Gibbs free energy change can be determined by taking the difference of the enthalpy of the system and the products of the temperature times entropy of the system. How this equation is used to determine whether a reaction will occur spontaneously or not is very simple. Here are a few guidelines that will be useful when calculating delta G for a particular reaction. If delta G of the system is less than 0, the reaction is spontaneous. If delta G of the system is greater than 0, the reaction is non-spontaneous. And if delta G of the system is equal to 0, the reaction is at equilibrium, and depending on the conditions, the reaction can go either toward the products or reactants. Chemical reactions are always taking place, and many of them can be observed on a regular basis. For example, the combustion of propane occurs when an energetic molecule reacts with oxygen to produce carbon dioxide and water. This particular reaction takes place every time a match is ignited to start a fire or burn a candle. Using the Gibbs equation and the guidelines mentioned earlier, the combustion of propane is said to be spontaneous because the enthalpy of the combustion reaction is negative as it releases energy in the form of heat to its surroundings. As energy is released toward the surroundings, the entropy of the surroundings increases, yielding an overall negative delta G. Combustion reactions are one of many spontaneous reactions. Spontaneous reactions do not necessarily occur if the reaction is exothermic. In fact, certain endothermic reactions can be spontaneous too. A non-spontaneous reaction is a reaction that does not favor the formation of products at the given set of conditions. An example of a non-spontaneous reaction is our atmosphere. Our atmosphere is composed primarily of a mixture of nitrogen and oxygen gases. One can write an equation showing these gases undergoing a chemical reaction to form nitrogen monoxide. This reaction is non-spontaneous at normal temperatures and pressures. It is a highly endothermic reaction with a slightly positive entropy change. However, nitrogen monoxide is capable of being produced at very high temperatures, and this reaction has been observed to occur as a result of lightning strikes.
Alright, I hope you guys are ready. Make sure that you have your everything put away. Calculators, pencils, erasers can be out. I'm going to start handing out the test. Make sure that it stays flipped over until everybody gets the exam.
The formation of this reaction has an enthalpy of formation of negative 104 kilojoules and a change in entropy of negative 60.8 joules per Kelvin at 30 degrees Celsius. What is delta G and spontaneity of the reaction? For this problem, I will need to use the Gibbs equation. I will plug in these given values and make sure to have the same units when subtracting.
Man, I should have not fallen asleep in class. I should have studied.
Putting this all in my calculator, I will get negative 8.56 times 10 to the 4th joules.
Damn, I can't get an answer. Let's take a look at my partner's work.
Next problem. The entropy and enthalpy of a reaction are both negative. Is the reaction spontaneous? For this next problem, I will also use the Gibbs equation. If delta H is negative, T is positive, and delta S is negative, the reaction will be spontaneous if and only if the magnitude of the enthalpy is greater than the magnitude of the entropy times the temperature. That was surprisingly easy.